Okay, well this is the other toothpick motor that I built up here, that instead of using the bent paper clips, I'm using these glass jewelry beads, and are plastic. I think they're plastic, and then the toothpick runs in those beads as bearings. And then I've got the rotor with a north on both sides, and because they were weak magnets, I could squish them together with the glue and form up a south pole in the middle, which is kind of interesting. This is the little driver unit I've got here. It's just a coil of 34 gauge wire, a reed switch, a 2.7 volt 10 farad super cap, and an LED that runs off the flyback when the coil field collapses. Let me see if I can get this to work here. There it goes. And this little device was rather interesting. It runs for quite a long time because the wire gauge is 34 gauge, and it's got pretty high resistance in it. And the motor to me is rather interesting. It doesn't make any sound unless you get really close and you can hear it running, but the interaction of those fields, the way that thing is formed up with that south pole in the middle and then the north on each end, is a little different than what I've done before, using these weak magnets. They're not very strong, they're refrigerator magnets. And that's what I've got going here, is this, I'll stop here. See the north on both sides, and then the south forms up in the middle here. If you put a compass or anything, it tracks in the middle, and I squished them together. Some people have recommended I put a piece of steel in the middle here to attract the south poles together, but I didn't need to do that. I just squished them together with crazy glue, and it worked pretty darn good. And that's my little second toothpick motor. Thanks for watching.